Good evening, everybody. I trust that you can hear me loud and clear, and also view the course outline I'm sharing with you. Can you hear me loud and clear?
Yes, Prof. We can hear you loud and clear.
And you can also view the course outline I'm sharing with you.
Yes, please.
Okay. We are back again to continue our interaction. Today we would quickly complete what we started the other time regarding the relational algebra. We will finish that one in a few minutes and we will move to look at how the relational algebra translates into queries. I'm sure we'll be able to finish that chapter as well, because now I want to believe that those who have never done courses in this area before would be finding their feet. And for that matter, we will need to start speeding up. There are so much we have to do, and where we are now, we are already lacking behind. So as you can again view the course outline, so much we haven't tackled yet. And today, this meeting is our 5th class, if I'm not mistaken. You will see that so far we are still within the first 3 lectures according to the course outline. And being the 5th class, we should have been on the 5th lecture. But I'm treading a bit carefully to get the foundation strong. And once the foundation is very strong, all this can be treated so fast and you understand. Okay, having said so, from next week, we will be diving into more advanced topics having to do with query processing, optimization, parallel and distributed database, concurrency, replication, and many other more advanced topics from next week. So today we'll run off with relational algebra and then also cover how the relational algebra translates into queries. Okay. As usual, anytime we come, I allow some 2 to 3 minutes for people who may want to ask 1 or 2 questions or clarification of some issue. If there is something like that, feel free and ask before we move on. Anybody who needs some clarification or question of a sort, otherwise I will just quickly move on with what we want to do today. Okay. When we met last Saturday or so, I did mention that when we meet today, I will introduce the assignments that we want to do. So I will soon be introducing the assignment to you. The first one, I gave it out some time ago, but I have done some little changes on it. This is the first assignment for individuals. You'll recall on our course outline, we mentioned that this course would also survey research in the area of database systems, as well as practical orientation as to put our hands to how database systems can be developed using best practices and conceptual models and relational models and so forth, applying the concept that we have theoretically learned from the course. So this assignment is a short, seriously a short paper that I want you to do. The essence of this is to concentrate on a particular area within the database systems that is of interest to you. And then you research into that area and you write just about 3,000 and 5,000 words. Hey. Why? Is it too much? Somebody say, hey.
It's okay, Prof.
Is it? It's very short paper, 3,000 words, just short paper, because one page is taking about 400 words. So just about 6 pages or so, or 7 pages, you are done. Just a very short paper. Now, this is how it will go. Anytime I gave this work out from experience, students do not read the requirements and they just quickly gather something and send back to the lecturer. But if you do it that way, you will be losing some marks, because just this paper alone is giving you as much as 20 marks. And then don't forget, the exam is giving you only 50 marks. The exam, and this paper alone is giving you 20 marks. So you will see that it's a work that you need to pay attention to. Sometimes students just gather anything, they don't follow what they have been asked to do. So pay attention to what you are asked to do. Some people even give me some survey results of some work that has been done, and then the survey results that are 20 people said this, that, but that's not what we are asking for. What we are asking for in this paper is simply to discuss the concepts, principles, theories, models, and then so forth in that subject area. So, for instance, if somebody wants to talk about relational models or database models as a whole, I expect that the person may start by, since this paper is basically literature review, the aspect of the literature review that deals about the principles, concepts, and so forth. So the person would then start talking about, let's say you want to talk about database models. The person perhaps may start about maybe flat file system, how it was faced with the benefits and how it was faced with challenges. You describe it first, and then that led to the development of maybe the next model, maybe relational models, when the advantages and disadvantages. You may draw some diagrams to show how it is like, and then you move on to maybe talk about the fact that it was also, though with all the advantages, it was faced with some challenges. And then that led to maybe people begin to look at object-oriented kind of database. Then you can move on to maybe things around data warehouse, how models, how they came about, and so forth. And you can trace it to today, what kind of data models are being used. So in that case, you are just talking about models, principles, concepts, and then all sorts of. So when you look at this very carefully, you will see that what your essay or literature review should be made up of is development and the current state of the selected topic. So you are going to talk about, maybe when you do all your discussion, you also want to know what is the current state of the topic. For instance, if somebody is coming to be talking about hashing techniques, you will discuss various hashing techniques and their strengths and weaknesses, and maybe do some sketches to explain to us what various techniques, what they concentrate on, what number of characters can be hashed, what size of, and so forth. Then you compare, contrast different hashing techniques. Then you can come to talk about maybe some of the current version, current hashing techniques that are being used in various applications, and then so forth. So that's the kind of thing that I expect to see in your paper. So you say you discuss key theories, models, concepts, principles, and so forth in the subject area. Then, after doing all this, you see, maybe more appropriately, I will put this one at the second point, so that somehow maybe it will follow chronologically. So, developments and the current state of the selected topic. Then you can also even predict. Prediction is generally from your own, based on what you are seeing in the literature. You predict the future developments in the area. So maybe after all this, you can link your work to say that maybe perhaps due to development in IoT systems, maybe certain aspects of hashing techniques could be deployed in the future in that environment. You predict. This prediction doesn't necessarily mean that it is true or whatever, but that's your prediction based on what you have learned from the literature that you reviewed. Then in your work, you are expected to cite at least 10 reviewed papers to support because all that you are doing is actually literature review. So they are not coming from your head. Where did you get them from? So you make reference to where you've gotten those, your discussion and then your evaluation, where do you get them from? You need to cite them. Your references should not be too old, but some can be old. For instance, if I want to start talking about a flat file system, this thing came up long ago. So maybe somebody who did the work on that at the time, and I want to cite that person, then that one could be old. But generally, in the area of computer science or technology, we expect your citations to be current. Most of the time within the past 5 years. The year I give it 7 years. And you can use the university adopts APA referencing style. So make sure you address yourself with the APA referencing style and use that one when citing and doing your referencing. When marking this paper, all these counts. Somebody will do the paper will don't bother about these points, and then you will be losing some small marks, and then so forth. So this is an individual work. Plagiarism will be checked, and if your work is plagiarized, it will be rejected. So don't copy. At this level, we don't plagiarize. At master's level, you will need to be able to do your own work and own your own work rather than copy something like the undergraduate where you just copy something and paste somewhere and then you go. No, not at this stage. You need to learn the act from now. So that those of you who continue with PhD, you don't go and struggle there. You already know what to do. Okay, so that is this paper. Any question on this, then you will move on to look at another thing. Feel free to ask for clarification if you so wish. Okay, yeah, Erasmus.
Good evening, Prof.
Yeah, good evening.
Okay, sorry to bring you back. I was not able to connect for the beginning, but I just end the what is your message. It's like you are giving assignment to us. So I'm sure that the assignment should be posted somewhere that we can find out and work on it, isn't it?
Yes, it will be posted. The sorry, I missed this one. The class rep of this class. Who is it? I think you sent me your this thing before. Who is the class rep?
John Bright,
Joseph.
please.
Is he here now?
No, he's
Yes,
not
please.
Joseph.
Joseph,
He's not here.
where is Joseph?
Maybe he's not yet connected.
Now, where's the deputy? We have a deputy or we don't have?
We have a deputy with a lady.
So where is she?
Please, by close of the period, this lecture, I want to know the class rep so that I can be communicating. Because when you go to Sakai and other places, Sakai, for instance, some people are not there and so forth. So we can start before we all get into Sakai and get things done properly there from there. I'll be posting it on Sakai where you may have to submit it eventually. But I can give it to the class rep. You can start working before Sakai issues are sorted out. Okay.
Please, Prof, when are we going to submit?
You submit this work a week to closing of the semester. So when it is 1 week to ending of lectures, but I'll be putting the date on it.
Okay.
1 week to the end of lectures, you submit it.
Okay.
So that's going to be somewhere January, is that not it? When
Yes,
we lecture will end, because we'll close and come back.
because we had 13 weeks, isn't it?
Yeah, you have 13 weeks. This time you have a long time. We used to even teach eight weeks. We even taught 6 weeks before.
Hey,
I don't know
you are
whether you are
fortunate. You are very fortunate.
It's supposed to
You are
do
very, very
it
fortunate.
a group of. Hello, Prof.
Okay. All right. So
Hello.
yes.
So I wanted to know, are we doing it in group or individual? And can you choose any topic you want?
I think I've shown the available topics. I've listed
Yes.
available topics. You can see the topics that I've listed. So your topics will border around this topic because these are the things we are coming to discuss in class. These are the topics that we are coming to treat. Each of these topics will be treated in class. So we want you to limit your scope to what we are doing. So you can choose from this. If you choose anything that is completely outside of this, then that's where the challenge will be. But anything related to this will be fine. Or anything from here, directly from here, will be fine.
Should it be done in a group or individual?
It's individual.
Okay.
It is completely individual. The theoretical concept on this paper is individual, but the practical one that I will show you very soon is going to be group work, but this is individual.
Okay. Thank you.
Okay. Okay. Thank you.
Hello, Prof.
Okay.
Hello.
Yeah, you can be talking.
Yeah, I want to ask, is there a format we are using for the paper since we have many publication platforms?
We have what?
Is there a format that we use for the paper?
I do not see any strict format so far as you address issues that are on over there. You saw the issues that you are supposed to address. You have to discuss concepts, models, theories, and so on. So anyway, you format yours, and then these things can be seen in your work. Developing a current state of the selected topic, evaluation and prediction of the future, and then so forth. I'm fine. Is that okay? Okay. Now, the next thing I also want to talk about before we delve into the lecture is this. I want to share this. Okay. I'm sure you can see what I'm sharing with you. This is a practical project. And this one is going to be hands-on. Completely hands-on. This is a group work. Can you view it from your end?
Yes, Prof.
Yes, sir.
Okay, all right then. So here, this one, as I asked the other day, the class reps has to give me the groupings. Ideally, there should be about 5 in a group, 5 students in a group. And this is what you are coming to do. I will explain it because I want every group to be able to do this work well. This one will fetch you 30 marks. I told you the other day that in this course, we are not going to have a sit-down mid-semester exam and so forth. So your continuous assessment is made up of the 20 marks for the theoretical write-up, 30 marks for practical work that you are coming to do. In actual fact, this work we are doing is going to be presented. The groups who are going to present their work to the class. When you see on the course outline, we have a day for presentation. So each group will present their work to me. So this is what you are coming to do. The other day I showed you some data. I will open it again, which is from statistical department. So we want to use that one to look on that one and start from the scratch. By one, carefully analyze the requirements and identify entities, attribute constraints, and so forth. Use them to draw a relational model and show relationships like one to one, one to many. And if there are many to many, go through normalization process and normalize them. Now create a database with these tables that you have identified. There could be quite a number of tables that you can find from that document. Create a database using Oracle or any relational database. Create the tables of all the tables you have identified. Make sure that when you create them, remember to incorporate these referential keys and relationships as you create the tables with appropriate data size, length, constraints, and so forth. Now, develop a simple interface, which could be, of course, it should be any of the object-oriented programming languages to the interface to interact with the database that you have just created with appropriate API to link your front end to the database. Then on your front end application, the user interface, put these simple buttons there: insert, retrieve, update, delete, and backup. Now, write simple scripts. We are not going to write for, you can just take one of the tables or few of the tables to create an interface for, because the tables are many. Once you can do that for one or two tables, nothing hinders you from doing it for all the tables. So you can just take maybe some 2 or 3 tables and get an interface, and then be able to write a simple script that could populate data from the form that you've developed and then save into the database. Then the retrieve tool, you should be able to retrieve data, update, and delete from the database. But here we become very specific here, over here. Here what we are saying you should do is that you are now coming to use the particular concept from what we are learning. This one, you write the front-end application to do it. Now we want you to write a back-end application that can insert data into the database using stored procedures. So you click on this an insert button, then the code behind will now call a store procedure to carry out the insertion. Now, also you can retrieve using a concept in databases we call cases to carry out the retrieval. Now, update, use store procedures. Delete, also use store procedures to carry out the deletion. All right, so then the next one is you need to use any join statement. You can join multiple tables because the databases that you develop or you design from the beginning, there are a lot of tables that need to be joined before you can retrieve data from them. So we want you to use some join statements to retrieve records from multiple tables. Now use concept of triggers to log user activities on a specified a specified table into the log table. We want you to use triggers that can help you to be able to log user activities into a table that you can create yourself, maybe audit log or something, so that you can log user, maybe username, user, which pages the user has attended, and so you can log all of them into that table. Now the next one, use any partitioning strategies. Use any partition strategy, any of the strategies. Partition one of your tables into 3. Then write a single query to retrieve records from all the partitions. So we will be learning partitioning strategies, and that will help you do this. Now the final one, under the backup button that you have created above at 0.4, I think, where is it? I think we did that at 0.5 here. In 5, write a script to take a backup of your database. Most of the time they did these things for us, so we only create buttons to take a backup. I want you to write a script yourself, the database script that can take a backup of your database. So now these are the things you have to do under the practical assignment, and this is a group work. I want every group to do this diligently, at least learn something new from this particular course that can be useful to you one day. Any question on this before we move on? Okay. We don't seem to have any question on this. So now I think the next
Prof.
thing I want to
Prof.
yes.
So now, if you happen to be part of a group that, so in fact, we don't know how to even write. The front end is a problem for us, sir.
That's the reason why you are there here. If you knew all these things, you wouldn't have come for your master, so you should have stayed in the house. If you knew all these things.
This is true,
That's why you are here, and then that's why I'm also here to teach you, and that's why I'm teaching you. You don't understand the logic. If you knew all these things, there will be no need for you to be here.
It's true.
So this is a learning exercise for you. I want you to know these things and be able to.
We appreciate. But what I will ask you to do for me especially is the group we have created. If you can send words across to the reps, that they should make sure there's somebody. The group contains somebody that has the know-how.
So but you form the groups yourself, so what should Prof do?
Because no, the groups me like this, I have a problem with the group that they create. I don't know. Each and every day they are removing. Each and every day they are adding. They are doing this. I don't know the
So
state
you
of the
form
groups
your
now.
group and add it to the list. That's what everyone is doing.
Today you inform me, tomorrow you do that. Today you inform me, you do that. I don't know what the whole thing is about.
Please, which cohort are you? Which cohort are you, please?
Cohort A, but I found myself in cohort B. I don't know how that happened.
Prof, what I want to say is this is Bright, the cohort B rep. The grouping, there was a problem because some people form a group with machine learning already. So when we were about to form a group, they said they have formed some groups in machine learning. So therefore, those two that didn't form any group in machine learning, they want to maintain those groups so that we will form other groups to add up to what is there already. Meanwhile, whilst we said they should add name for us to form group, people, some of them were not following information. So they were part of the machine learning, but they still came and give their name, and it has mixed up the whole thing. The extent that yesterday and a few days ago, other people are calling me that they are in cohort A, but they didn't get group, so they want to join the cohort B to form group, and the whole thing has become some way. So I don't know if we have to reform the whole group again and forget about the machine learning thing that will make the thing organized. That is why I didn't even send my list.
But how do you bring a cohort? How do you call it? A machine learning group to a different class database?
But
it
that's
has
the
to be
problem.
solely
That is the
database.
problem I have.
Because some people do machine learning and they are not in database class.
Yeah. It will even create more problems.
You get the point. So if you bring some people from there, it will just confuse the whole thing.
So we should just quash the group. We should quash the
form new groups. That's all.
Let's just do new groups and then we'll be free. It's for just this program or this course.
And I think the group two should be formed based on the cohort. So let's say if you are in cohort,
if you are cohort A,
if you are cohort A, that is it.
If you are an MPhil student, you form a group with an MPhil student. If you are a cohort B student,
exactly. If you are
Yeah, that will be more manageable.
Yes, so that when you start the face to face, you will not be found wanted. Because when you start face
so if you are in cohort A,
in that case, I will announce to them that we will reform the whole group and we forget about the machine learning group they are trying to maintain and form a new group.
Exactly.
I send them.
Exactly.
Thank you.
Hello, please,
that is the best thing to do.
Yeah, so please, is it possible we can continue with what we are doing? Just that those who were left out because of this controversy about machine learning and database, they should just continue and join the list instead of scraping everything off altogether.
Okay, as long as cohort A people remain in cohort A and MPhil remain in MPhil lane. And then,
okay, because some people have indicated that they are in cohort A, despite the controversy that has happened, or B or C. So if we can just clarify that without scraping the group.
The way they form the group, the problem is some people are in 3, others 4, and whilst others are 6.
Exactly.
It has made the whole thing some way. So I think we should reform the whole thing
from the scratch. Simple.
Okay.
What?
So now,
those who are
fighting, let me just come in so that we can continue. Otherwise, we wouldn't be able to cover the lessons today.
Yeah.
So take your time and form the group. The group should be based on your cohort.
Okay, I'll go.
So cohort A, B, I think C are not here with us. Am I right? C belong to a different group. Is that not it?
C belong to other database so they are not part of
it. They are not part of what we are doing here. So
yes.
Cohort A, B, and then the MPhil. These are the 3 groups that I have. MPhil should form their own group. They can maybe get 2 groups or so. Then A should form their group, B should form. It makes marking and other things easier for me as well because when we do things this way. So take your time and sort that one out and let me have the list.
Okay, Prof. Thank you.
I think that will solve this problem. But I'm sure the cohort B people are here with us today, over here now.
Prof, your GA announced to me and he was looking for me, and then I DM him. He gave me the information and I announced it. So those who might pay attention to your WhatsApp, I'm sure they know that and they will be here.
And when I see the numbers, I realize a number of them are here actually. But those who are not able to be here, the teaching assistant, we are doing recording. So they shouldn't miss out completely. We are doing a recording of the class. I hope these recordings have been made available to you.
Yes, Prof, but the last one, we've not gotten it yet. The last one, the last lecture, we've not gotten the recording yet.
Regarding the recording, I work with my teaching assistant. Fortunately, it happens to be part of you. So, you know my teaching assistant, Prince.
Yes, please.
He is doing MPhil. He is doing MPhil, so it's part of you.
I communicated with him today.
So he can be making the materials available to you.
Okay. Thank you, Prof.
So now that we have sorted those things, let me just briefly show you this and then we move on to what we want to do. You see, the nature of what I'm teaching is that I don't want us to finish this course and you can't do anything and everything will just remain mere theoretical or one of those things that you've passed through and you get some grade. So I believe that if you sit down and then you do this practical exercise and so on, even if you don't use it for anything, you can speak intelligently if some of these things have been done or some project that you need to supervise and then so forth. You can contribute meaningfully to discussions in the development of databases and so forth. So now there is the material that you are coming to use, the basic material that you are coming to use to do your work. It's quite comprehensive. If you don't look at it very carefully, getting tables from here, fields and other things, linking them can be a challenge. But those who have now done this before, they are afraid that they may find themselves in groups and so on. I wouldn't mind because it is a project, you can get knowledge from other people, you can ask questions because you are learning. If there is somebody in another group and he understands these things, your group can get in touch with the person to explain some of these things to you. What I don't like is a copy work. And if you copy, I will know. So it's a copy work, but to gain knowledge from members of other group to explain things to you, there is nothing bad about it. After all, master's level, who is competing for grades? You see, master's is either you pass or you fail. There is nothing like first class, second class, and so on. And so it's either you pass or you fail. So please share knowledge. The same people you are sharing knowledge with today, they are the same people you'll be meeting all the time, because once you have been a classmate, you will become, so to speak, colleagues forever. So share knowledge and learn from each other and get this thing done properly. Okay, having said that, we can now.
Prof.
Yes.
Please, in the group, I've seen cohort B, in some of the groups into brackets cohort B. So I don't know if that group, because I'm currently not in any group, and I don't know if that is the group
Are you now joining the class? We've talked about this grouping already. Maybe you are now coming in.
No, they still the same group.
We've settled on that one already. The class reps are going to work out the grouping for me.
Please don't worry. We'll dissolve the group and reform so that you understand, please.
Yeah, okay. Thank you.
Okay. So that takes us now to what we want to look at today. Let me just What's happening? Okay. Okay. Hopefully you can see what I'm sharing with you now. And
yes, Prof.
Last week, we were discussing mathematical foundation to data manipulation language. We saw quite a number of interesting representations of queries. We came to join operations. That's where we left off the other day. Today we'll complete that, and God willing, complete another chapter. Because once you understand this, the others are now quite easy. So we saw selection, projection, partition, product, union, intersection, set difference, natural join, semi-join, left join, division, and so forth. We talk about selection and then projection, that they normally deal with only one table and also produce only one table as a result. So you will see prediction dealing with only one relation, projection dealing with only one projection with appropriate symbols. Then
you just moving forward, bro.
Set difference, we have union. Then we talk about union when we want to join records from two tables. But then there must be union compatible. The field in one relation to have a corresponding field in another relation, then we can join them. Then we have a set difference. We talk about all the. Please, if you have your mic on, just mute it for now.
Hello, Prof. You're muted.
Is someone talking?
So all this time you weren't hearing me and you were quiet.
You are muted, sir.
You can hear me now.
We're not hearing you, Prof. We're not hearing you, Prof.
When you were not hearing me, and when you were not hearing me, you were quiet and I was talking into the air.
No, we thought that you received a visitor, so we were waiting for you.
So we thought that you were intentionally waiting to do something.
So what happened that the system got me muted?
We don't know, Prof.
Anyway. All right, so. But you were seeing the screen that I was moving up and down. You were quiet.
Yes, sir.
Those things that I said already, they are gone. So maybe I'll continue from where I am now. The more critical aspect is the Cartesian product.
Hey, Prof, we to go back more for our back.
No, the issue is I'm only reviewing what we learned last week. So there was no critical need to go down there.
Okay.
It was merely a review of what we learned last week. What is actually critical for today's class is where I am now, Cartesian product operation. So now, with the Cartesian product, that's where we have a problem. The number of rows in one relation will be multiplied by the number of rows in another relation. So if you have 1,000 records in one relation, 10,000 in another, then 1,000 times 10,000, which can be very large, also depending on the number of columns they contain. So for that reason, it is from here that we begin to develop various kind of join operations. So you will say natural join, theta join, left join, right join, and all sort of joins, because they are all further operations being performed on Cartesian products. Okay, having said so, last week we saw the first two of them, which was the theta join and then equijoin. What we said about theta join is here, that theta join has to do with adding some predicate to the relation. In fact, if we remove this f from here and we just say r summation, somebody said this summation symbol, s without the f, then it is completely what we describe as the Cartesian product, where everything will be multiplied. But we can limit it by saying that, okay, use this filter to say that where certain condition occurs, or we are joining based on certain criteria, and that is a predicate that we normally talk about. So here we can pick a particular field in this table and say if it is the same as the one in the other table. And when we say something like that, we limit the data that have been retrieved using the Cartesian product based on, or we limit it according to the predicate over here. So that's why we can even explain here, if you look at this, that the R times S is just Cartesian product, but then we limit the selection by a predicate F. We saw something like this the other day. The predicate can work with comparison operators, where we have less than or equal to, greater than, not equal to, and so forth. Okay, so that is the theta join. But there is a special type of theta join that we talk about, which is the what we call the equijoin. Equijoin. That one, it is when the comparison operators become equal symbol. The moment we are using the symbol equal, then we now have the equijoin. So you will see from this example, as we join two tables, client and then viewing, and we select certain fields from them. When you look at the predicate is saying that client number in client table must be equal to client number in viewing table. Because this symbol is equal, makes it equijoin. But if we change it to any of other symbols, it will not be equijoin anymore.
Prof, please, can you zoom in small? I can't see it so well, so that I can see the whole equation.
Is it better now?
Thank you, Prof.
Now?
Yes, please.
Okay. And so the point I'm making is, it is this equal symbol in between or in the predicate here that makes this one known as equijoin. But if you use any other comparison operators apart from the equal, then it's not equijoin. So by so doing, you will see that when we just merely join, let's say merely fetch data from client and viewing without this predicate, it will fetch a whole lot of data by simply multiplying records, the total records in client relation times the total records in viewing relation, which can be large depending on the number of records in them. But we can limit it by putting a predicate that, okay, do so by just the client number in client table and that. So that limits the number of records that we want to fetch. So it will trim down the total number of records that might have come through Cartesian product. Okay, having said so, from all the join operations that we are coming to look at, as I said, they are all based on the Cartesian product. But we are looking at which tables are we fetching from, how are we joining them, what kind of data are we retrieving, and so forth. Okay. Now the next one that we want to take a look at is natural join. Natural join. This talks about the fact that the natural join is an equijoin of two relations. You see that we are saying that it's also even equijoin. R and S over all common attributes X. So the difference is common attributes X. One occurrence of each common attribute is eliminated from the result. So let's say, what example can I give now? Let's say this example is explained. Let's see this example. When you look at this client and viewing, immediately you know that it's a Cartesian product, because we do not have the predicate here to limit the scope. But for natural join, what it does is it will go and look at the matching attributes in both relations. So when you look at this relation here, you see client number, first name, last name. Here you see client number, property number, comment. The common attribute in both of them is client number. So it will do the join based on the common attributes in both relations. So assuming here that we have maybe first name and we still have first name in the viewing table, now it is now going to join it naturally using the two common attributes. But in this example, we have only one common attribute, which is client number. So automatically it will see, because when we are creating tables, client number here, if this were programming language, I say the signature of this will be the same signature here. For instance, the data type of client number, the size, and so forth will be the same as this. So automatically the system sees to know that this and this, when you are joining these, to naturally you have the same signature to join them as natural join. So if you have first name here and a first name here, automatically it will join them. So that is a natural join operation. I just hope that it is understood. If it is not understood, You can ask questions, or you can keep quiet and understand it by and by.
Prof, I was just seeing only one. Were you demonstrating something? Because the page was stuck on the fourth page.
The
I mean
my mouse was not moving. Is that the case?
Yes. And it's like you were comparing some tables.
Okay, I was talking about the. Is my mouse moving now? It's still not moving. You can't see the mouse.
We can't see the mouse.
But you can see my highlighted. You can see my highlighted formula over here, having to do with client and then viewing, the one highlighted in green.
Yeah, you can see this one.
How do I make sure the mouse is working? Who can show me what to do? This is computer science master's class, so you should be able to resolve that.
Well, I think when you are moving the page, I'm sure that the second table that you wanted to compare is down the first one. So far you cannot see it. I mean, so far I didn't, the camera doesn't see it. I mean, we cannot see it. So move the page to the top small and it will come. And you will see.
I should do what?
You should move to the second page, or where the second table is, because it's only the one table that is showing. Maybe so it's only one that we can see right now. So move it again and see maybe.
There's only one table, or there's only one table on this page.
Okay. So, but when you were talking, it seemed like we are comparing two tables.
Yeah, the formula that we are talking about, there are two tables. The client, the formula in green, there are two tables, client and viewing.
And what is the second table?
I'm talking about the formula. In the formula, can't you see client, and then can't you see viewing in the formula? In green?
We can see it. We can see it.
They are the tables.
Okay.
So in the formula, we have both current number in both tables.
Yes. So naturally, even though you don't have anything there as the predicate, as we saw in the previous one, naturally, since the client number is in viewing and client number is in client table, it will join the two naturally. That's why we call it natural join. Unlike the
Hello, Prof.
Yes.
Please, if to your left of your screen you will see a menu bar of pointers to your left.
Yes.
If you can toggle between some of them, probably it will bring the cursor back. So you can click maybe the second one. And
is it back now? Is it back?
Okay, all right. If you are moving it, then it seems it's not back.
Let me just go. Is it back?
No, Prof.
It's still not back, man.
No.
But was it working earlier today, or it never worked?
We didn't take notice, I think so.
We didn't take notice of it.
Yeah.
So our mind hasn't gotten on it.
So it's still not back, eh?
Can you please stop sharing and reshare again?
I think that's what we need to do. Let me just stop. And sometimes even these things happen for some funny reasons. Let me share it again. The way this thing is, if you don't see the mouse moving, it sounds abstract. Is there any hope? Is it viewable?
No, it's not.
It's doable. So probably we can go. Although we can see the arc of the mouse, but we cannot see the mouse, so you can go ahead.
You can see what?
I mean, we can see the actions of the mouse. When you are scrolling the page, we can see.
You can see the pages, but
we cannot see the mouse. So
the mouse pointer is what you cannot see.
Maybe, Prof, we could try the pen one, so that you can use that to highlight, to underline the words you want to draw attention to, if the mouse is not coming.
Okay, now I'm trying to highlight something and see whether you can see. Can you see what I've highlighted now?
No, please, not yet.
I've highlighted a portion of the screen.
Yes, please. You can see.
We see that. We see that.
Like you can see. Okay. Okay. All right.
Is it the green one?
I just highlighted something to check whether you can see. The green one, the light green. You can see the light green one that I highlighted.
The text highlighted.
Okay, okay. I'll see it.
Okay, so maybe we can be using that one for me to be pointing at things for you. Okay, so we are talking about the viewing. And so natural join, what it means simply is that a field in one table corresponds, not a field, fields in one table corresponds with fields in the other table. The database will join them in the join operation. So in this case, you don't need to bring any predicate to say client number in client table, client number in viewing table, join together with equal symbol or whatever. It will automatically join them. And that is what we call natural join. Okay, having said so, we will need to move down to outer join. The outer join looks like this. Maybe since you are not seeing my mouse, let me just do this. Okay. You can see the highlighted portion here.
Very clear.
The left outer join, look at the symbol. It looks like a greater than symbol pointing to the R. Okay, the left outer join is a join in which tuples from R that do not have matching values in the common attributes of R are also included in the result. So see it as to understand this very well, see it as some records from relation R also add up to the joint operation of R and S. So that's what we mean that tuples from R, records from R that do not have matching values in the common attributes of S are also included in the result. So when we issue that kind of command, you may see that because some